Okay, let's try this again. Okay, let's try this again. All right. So this time, what I want to do is set up from scratch. So let's check to see if Go is installed on my machine. And we're going to go ahead and open, not TV. Quit TV. I just wish I could quit TV. So let's open Terminal up. And let's take a look at Go. Okay, Go's already installed. Alright, so Go's already installed. So I'm going to go get Visual Studio Code. And I believe technically it might be installed. No, it's not installed on this machine. So let's go ahead and get Visual Studio Code. And we're going to download. And since I'm on a Mac, download for Mac. Okay, when it finishes downloading, just open it up. Okay, so on a Mac, to actually make it like a regular install, I'm going to open my downloads in Finder. Yep. Opens in the other window. Okay. And I'm just going to copy this to I'm just going to copy it to my home directory for now. Okay. And we can create a shortcut to it over here. That's great. Okay. So now with that done, go ahead and close this. I'm going to fire up Visual Studio Code. And I'm going to do File, Open Folder. And let's see, we'll use Get Going. We'll create a new folder and Get Going. We'll call it Projects. And within Projects, we'll create a new folder called Get Going 2 for today's Get Going. Wow, today is really not going smoothly. All right, so we've got a folder. We're going to create a Go file in here, and we're going to call this getgoing02.go. And it's going to ask me, do I want to install the recommended extensions for Go? And I'm going to say, okay, let's go ahead and install. Go Out Loud is not available. Let's install all of those. And it'll just take a second here. And what it's doing is it's automatically going out there and installing those Go projects for me, so that I've got all the fancy features like auto-completion and debugging and linting and all the things I would want as a regular Go developer to be able to write Go. That is great coffee. And this is building them by pulling the source code and just running the Go compiler to generate the executables. All right. If I do this one, it's already installed. Look at that. It says all tools successfully installed. You're good to go. Okay. So I can close these windows and let's go ahead and make this big screen. All right. And I want to open up a terminal. So there was one thing I didn't cover yesterday, and that was Tuesday. And those were modules. Modules allow us to have code in Go that describes its dependencies and where it would normally be located. So I'm going to go ahead and initialize this module as with the command, and let's make this bigger. So I'm going to use the command go mod init, and don't worry about what this does, but you know, for right now, make these just magic strings that you use. Go mod init, github.com dark ink get going 02. This doesn't actually have to exist on GitHub. I'm just creating a module, and the module wants a location for the module root. So, but Go is smart enough to realize that we're editing in our local folder. So let's go ahead and create a package for this, and this is going to go into main because it's going to have a main function. Just saying, if you don't do this go mod init, some things won't work as well as they should in terms of the ability of the Go tools to syntax highlight and everything else correctly. Without getting into it too much. So anyway, we've got we've got our main function, and from the last time we created a variable. We said was sum int equals 3, and we used the FUMP package, the format package, to printf value of sum int equals %d. All right. If we save that, I used an equals. I should have used a colon equals to declare and allocate my variable at the same. Sorry, to define and define my variable and give it a value at the same time. All right, so we did that. So we kind of glossed over some stuff, and one of the things we glossed over is func main. And Go is one of those languages where everything is a first-class function, meaning that everything has it's not like functions are just code that you write. They're actually things you can pass around. And so Go has a pretty nice way of handling functions, and you are going to write functions early and often. So you're never going to just have just your main code or just your main function with a whole bunch of code in it for your program. You're going to split your program up into chunks, and those chunks are going to go into functions. And the cool thing in Go is these functions are not just instructions to run, but they can also be passed around in and of themselves. We won't do that quite right yet, but what we'll do is we'll go ahead and define a new function, and we'll call this first function. and we're just going to use open and close parentheses to indicate that we don't take any variables, and we're not returning any variables, so we don't have to define any return variables. And here's the body of our function. So inside of a function, just like main, which is just another function, it just happens to be the function that Go will look for when starting this program when you run it as a standalone program. So Go handles either standalone programs or libraries, and standalone programs will have a main function and will be in the package main. So let's go ahead and do something. We'll say println hello from first function. Now, just as we are able to, we don't have to call main, but printf is just a function on the func package. So we can go ahead and call first function, and if we run this, we see that we get the output from the first function. So the execution of the program starts in main. It allocates a variable called sumInt. It then executes this code to print the value of sumInt. Then it calls first function. And when it does this, execution jumps to first function, runs this code, and returns back to main. So if main had another statement in here like Rocky, start today, OBS catastrophe. If I run this, and notice today we're using go run dot as opposed to go run the program name, because we initialize this module with the go mod init command. So we see that control passed from main to first function, it executed inside of first function, came back to main, and we continued to main. So let's have first function, let's define another function. This function we'll call random dice. And in this case, we're going to take two parameters. We're going to take, well, let's take one parameter. We'll take number of sides, and that will be an integer. And the program will return an integer. So when we have a function, here we had a function that didn't take any parameters and returned no parameters. Here we have a function that takes one parameter. The parameter name is number of sides. So inside our function, we can do funct printf number of sides and add number of sides. Okay. Now, because we're saying we're returning an integer, we do have to return something. So in this case, we'll return a 0. And now we can go ahead and call random dice, and we're going to give it a 6 for number of sides. That's your traditional dice, right? Notice that we had, before we did this, we had a yellow squiggly here. That yellow squiggly indicates that this function is defined, but it's unused. Those are the kinds of nice warnings that we get from the Go tooling. It isn't just Go, it's also all the other linters and stuff associated with Go, but we get these nice warnings that say, hey, you put this in here, but you don't use it. Did you really want to do that? Okay, so let's call random dice. And let's go ahead and run. And okay, so we see number of sides, 6. Okay. Just to show you we're getting a value back, we're going to create a new variable called returned value. and we are going to initialize it from the call to random dice, and we got a red squiggly because we're not using it, so we'll go ahead and use it. And when we run this, we see that the code began executing, it allocated summit, it printed the value of summit, it jumped to the first function, it ran the code in the first function, jumped back to main, defined a new variable by executing this function, so it dropped down into this function, executed this code, returned a 0. The return value from that function was used to initialize this variable, which we printed out. So there we go. Lots of stuff going on, but pretty simple in concept, because what you're basically saying when you call a function is you're jumping into that function, you might be passing it some data, and you're returning some data. Okay, let's go and do something interesting with number of sides. Now, we've been using the func package, but we also can use the rand package. So let's take a look at rand. And I think what we want is rand int. Oh no, that's not what we want. We want rand. I don't think we want crypto rand. Let's take a look at rand again. Let's do rand new. So when we call rand.new, we get back a value called rand. So we're going to call this myRandom. And what else? Not enough arguments to brand new. Okay, so as I sit here and I'm trying to figure out what rand does and rand new does, oh, I have to give it a source. So a lot of times I wanted math.rand. So a lot of times I want to go to Golang golang.org under packages, and I want math. And within math, there's a sub package called rand. And yeah, that's exactly what I wanted. I wanted rand int. So rand int. So there's crypto.rand and there's math.rand. And originally I picked the one from crypto, but let's pick the one from math. So myRandom all right. So let's say fumped. So let's take out some of these. Let's get rid of this and this since we don't need it. And let's get rid of the call to first function. And we're going to get rid of first function so we can focus on what's important here. And if we run this code, we said number of sides is 6. That's what we passed in, right? And then, when we call random dice, let's start at the beginning. So we call random dice. We jump to random dice. The first thing random dice does is allocate a new random number, and we place it in the variable myRandom. And let's get rid of printing number of sides since we've got that already. And so we print the number of sides, and then we print my random is the value, my random, right? What I want to do is, and let's define this here, return a die roll based on the number of sides. So I want a value from 1 to number of sides that is random, as if it should be as if I rolled a die with that many sides. Okay, so there is, I mean, most people are familiar with, you know, the regular mathematical operators like 2 plus 2 and 2 minus 2. But computers do something interesting when we do say 3 divided by 2. When we do that in a computer with integers, and last time we talked a little bit about things that were integers and floating points, and how integers are just the whole numbers and floating points represent fractional values. Because integers can't represent fractional values, when we say 3 divided by 2, and it's not 3.0 divided by 2.0, which would be 2 floating point values divided by each other, but when we are dividing 2 integers by each other, the computer doesn't have a half integer. It has a half floating point, but not a half integer. So what it does is divide those values basically truncating off the remainder. So let's go in here and say, let's just run a little experiment. So from our main function, we'll do printf 3, 2, and we'll have the computer do 3 over 2. And we'll do and finally we'll do so what we should see is 1, because what will happen is 3 divided by 2 is 1, remainder 1, and the computer will throw away the remainder because it's an integer. 4 divided by 2 is 2, remainder 0. So we should see a 2 because there's no remainder, and it's fine. And here 5 divided by 2, we should see 2 because 5 divided by 2 is 2, remainder 1, and integer division throws away the remainder. So if we run this, that's what we see. We see 1, 2, 2. Now, if we said remainder equals, and there's a way we can ask the computer for the remainder. We can say 3% 2. That percent is called the modulo operator, and it gives us the remainder of the integer division. So remainder okay, we run this again. Now we see that 3 divided by 2 is 1, remainder 1. That's what you learned in grade school. 4 divided by 2 is 2, remainder 0. Great. And 5 divided by 2 is 2, remainder 1. Now, if we want to get as we saw here, our random value is this huge number, right? In this case, it's not random, it's the same number all the time, but that's because we aren't seeding the random number generator, but let's not worry about that for now. So it's this very large number. Well, if we divide that number by 6, we'll get if we divide it by 6, we get the integer value of that division, which would be some other big number. And well, let's just do it. Let's just do func printf my so we'll do all right, let's do that, and let's spell func correctly. If we do this, and let's comment these out for now, if we run it, we see that this giant number is this with remainder 2. And this will be what I'll get is if let's say, for example, if number of sides is 6, I'll get a situation with the number is divisible by 6. If number of sides equals 6 and the random value is evenly divisible by 6, random modulo 6, the modulo, that's how we spell it, will be 0. So if the random value is evenly divisible by 6, my random modulo 6 will be 0. If number of sides is equal to number of sides equals 6 and random value is not evenly divisible by 6, I'll get a number from 1 to 5. So you see how that works? So let's say the random number came back 12. 12 is evenly divisible by 6. The modulo is 0. Let's say it came back 13. 13 is not evenly divisible by 6, and we get, like we got with the integer division below, we get 2, which is the 12 part of it, with a remainder of 1. So the modulo will be 1. 14, again, not evenly divisible by 6, so it'll be 2, remainder 2. 15, or sorry, 13, 14, 15 would be remainder 3. 16 would be a remainder 4. 17 would be a remainder 5. But once we got to 18, 18 is evenly divisible by 6, so the modulo, the remainder, goes back to being 0. So what we want to do is actually say my random is actually ran.int modulo number of sides, right? And then because we want the value 1 to 6 for the die roll, and the module will be either 0 because it's evenly divisible, or 1, 2, 3, 4, 5, we need to add 1 so that instead of 0, 1, 2, 3, 4, 5, we get 1, 2, 3, 4, 5, 6. Okay. So let's go ahead and get rid of this. And let's go ahead and return my random. And let's get rid of this print statement in here. So now, when we run this, we see the return value is 3. Now I talked about how we need to initialize the math.random. So every time we run this, we'll always get 3 because the random number generator hasn't been initialized. So we're going to go ahead and do that. We're going to say rand dot seed, and we need to give it a seed source, and we want that to be random, and the best way to get that is time. So time is another package which brings the time functions into the system. Time dot now, and this returns a it seeds it with the current time in milliseconds. So let's separate that out from the rest of our code. So this is just some bookkeeping code. Notice I haven't been worried about these import statements because once we use the Go tooling in Visual Studio, it takes care of managing these import statements for us. We don't have to. It even alphabetizes them so they're in the right order. But what we're doing here, and we're getting the current time, so time.now, and then we're asking it to pull back the time in milliseconds. So this will seed the random number generator with the time that we happen to be running this program. So now if we run it, there we go. The first one happened to come back 3, but now we're getting random values back, right? So we're getting random values back. Okay. So let's take a brief look at what we covered here. We covered creating our own functions. We covered one of the most useful pieces of math I think there is in computers outside of addition, subtraction, multiplication, division, which is modulo, which gives us the remainder of an integer division. We covered passing an argument into our function. We covered returning a value from our function. And though we don't want to get into it, we did cover a little bit of, we did see that there is a time package so that we can get the time. We looked at the random package to get a random value. And we took a brief kind of look at setting this up as a module. So we could, in fact, use things like go run dot as opposed to go run the program name, which is just a convenience. But it'll become, it's something I want to introduce now to give you a chance to become more familiar with it so that when we use it more, it'll make a lot more. You'll be able to add your other libraries and those dependencies will be listed here in the module. But I just want to get it familiar so that it's not, you get used to typing it out. And that was go mod init, and then we had to give it a location name. And I gave it github.com, and then my GitHub account, and then get going 02. It doesn't really have to exist on GitHub. It's fine. It just needs a location. All right, and finally our program is able to roll an ostensibly random 6-sided die. All right, that's it for today, and I will See you next time.